Okay, what is going on, guys? Today we're going to use Wireshark. We're going to ping and do some trace routing, and I'm just going to compare the results using Wireshark. So, as you can see on the screen, I've already pinged. Our host is going to be www.yahoo.com. So the top one there is pinging yahoo.com. The bottom one is trace routing, and the results are behind in Wireshark, and we'll definitely go over those. So, some differences between pinging and trace routing here with these statistics. Pinging really is just pinging one address. You're just trying to see if that host is reachable, compared to a trace route, which is sort of more finding the route, and it's bouncing around a lot to different routers and hosts and things. The size is pretty different. That's really the length here on Wireshark. So pinging can get up, it changes a lot. You can see it gets up to 219, 228 here. If we scroll down though, trace routing, this is where we get into TTL a little bit, and the time that exceeds. So when it hits 174, trying to hop to a host and it can't, then it hops off and really just moves around and it gets off of that. So there is a limit to trace routing where it's trying to go quick compared to pinging here. So the value of the upper layer protocol, we can look at some of these here. Like I said previously, 174 is the highest for trace routing. Okay, so I think that they do that because the trace routing is trying to find the best path to the host. So then the upper layer protocol compared with pinging and trace routing, you can see a lot of the pinging here is DNS. The protocol is DNS for pinging a lot, where you can see trace routing sort of bounces to all these different protocols, ICMPv6, TCP, ARP. You can just read through the list. So pinging is very simplified compared to trace routing. But so like for TTL, what we were talking about earlier, trace routing this is for trace routing only. Okay, this is not with pinging. It's basically the time to hop, and when it can't reach the destination, it expires. So how trace route works with Wireshark, with the file capturing evidence, is really you start a Wireshark session here. I'm on my local area connection. You can see down up here, you select that, you start running Wireshark, and then you come back to the command prompt and you actually start a trace route to yahoo.com. So let's go into question number 3 here. According to the ICMP fields of the ping packets, what type of field in the echo request and in the corresponding echo reply? So we can see the requests here. We're going to actually go to ICMP v6 here. That's what mine is. We're going to hit go here. It's going to bring us here. Now, this for trace routing. So this sort of takes us, this protocol is only for ICMP v6. You see there's a lot of time exceeded. But let's look at these statistics here. So the request and the reply. The ID for this is always 0x001. Okay, so that's what it is all the way throughout. You can see we can go all the way to the bottom to the end. ID is still that. Okay, some fields are matching, but a lot of them aren't. So like the sequence number, when it sends a request, the reply comes back as the same sequence number. So the sequence number matches. Then when it sends the next request, the sequence number goes up by 1. The sequence number from the reply is the same. Okay, but the numbers never always match up. Okay, the hop limit always changes. The request in, that number changes a lot too. So you're never going to find the same numbers here, even if it's the same request to a reply. It never lines up 100% the same. The sequence number is the same and is matching, but the hop limit is different. So that is that's really all. You can see that it's pretty interesting to look at some of this stuff. Basically, Wireshark just gives you a even more in-depth look. It's sort of almost or like categories. Ping is very simplified. Traceroute gives you a little bit more information, and Wireshark really brings them together and gives you a lot of information. Thank you very much, guys, and that is all.